Greetings, folks. Professor Fiore back once again. Today we're going to talk about scale. Specifically, we're going to look at the Earth, the Moon, Sun, and Mars. What are the real sort of distances? It's one thing to see numbers, but let's try to draw a picture. So we're going to start off with maybe something you've seen on a news show, magazine, whatever. They would show maybe something from the Apollo days, and they would draw a little picture of the Earth. So I'll just say, that's the Earth. Then they'll draw the moon, somewhat smaller, and they'll say, okay, we're going to launch, do some orbits. We'll come out here, do some orbits, land, get some rocks, take some pictures, whatever. And we're going to come back, land back on the Earth. Scale, this thing is completely messed up. It's totally wrong. What does it really look like? As it turns out, you can't really draw this to scale and hope to put it on TV, put it in a magazine or something like that. It just doesn't work. So what we're going to do is we're going to start with the Earth, try to build up from there. So we start with the Earth. It's 8,000 miles roughly in diameter. So if I shrink the Earth down to the size of a U.S. quarter, right? The U.S. quarter is about an inch across, about 2.5 centimeters. So I say, all right, this is going to represent the Earth. This is our scale, okay? So I'm just going to draw a little Earth for that. Right, there's my Earth. The moon, instead of 8,000 miles, right, 13,000 kilometers, thereabouts, is about a quarter of the size, maybe 2,200 miles, okay? But the distance varies a little bit depending on the orbit, but roughly we're talking maybe 240,000 miles, okay, about 400,000 kilometers. Wow. You start thinking about that and you say, well, geez, if this is 8,000 and it's 240,000 to it, well, that's a factor of 30. So my 1 inch becomes 30 inches, right? So this is a 4-foot board. So 30 inches is going to be, about here. And there's the moon at about a quarter of the size. So that's the real scale that we would have, okay? You can imagine you shrink this down, to the size of, an 8.5 by 11 sheet of paper, and you're just going to be left with dots for these things. The scale kind of goes out the window, all right? Okay, well, where's the sun in relation to this whole thing? So the sun is about 93 million miles from the Earth, all right? So if I were to draw these in line, you think 93 million miles that way, okay? So that's going to be somewhere in the 140, 150 million kilometers. Where does that wind up? Well, that's a factor of nearly 400 to 1 versus the distance to the moon. In other words, the sun is about 400 times farther away from the Earth than the moon is. Okay. Well, if that's 1 inch over here for the Earth, 30 inches out to the moon, it turns out that's going to be somewhere around 1,000 feet, about 300 meters that way. So that's really hard to draw to scale. All right, try to put that in a magazine or on a web page. How big is the sun? Well, it's about 900,000 miles in diameter. It's about 110 times the diameter of the Earth, right? So it's going to be bigger than this board, right? It's going to be way bigger than this board, okay? So there you are, 300 meters out that way is where the sun is. What about Mars? A lot of people talk about, hey, we went to the moon. It's time for us to go to Mars. Seems logical until you start looking at the distances. Well, how far is it to Mars? That varies a lot because the Earth's orbit and Mars' orbit, right? Where are Earth and Mars in their orbits? They're not in sync. So sometimes they're on the opposite sides of the sun. Sometimes they're on the same side, right? Sometimes they're in line. On average, about 140 million miles. Okay, what's the closest approach? Well, it's around 34, 35 million, but that happens very rarely. So, you could maybe hope to get within about 50 million miles of Mars. In other words, about half that distance that we have to the sun. But, if you're just going to say, well, on average, like I said, it's actually further away than the sun, about 140 million miles versus 93 million miles. Well, okay. Now you start thinking in terms of what's it going to take to get there, right? So if I'm going to go from the Earth to the sun, that distance, like I said, is around 400 times this. If we're lucky, we can get about 200 times the distance to Mars. All right? Okay, so imagine, let's put this in human terms. Imagine you decide to go for a little walk, right? You're going to go out of your house, walk down the block, maybe about a mile, okay, 1,600 meters or so. You turn around, you come back. Right? So it's mile out, mile back. So you got, a couple of miles in there, a little over 3K, in metric. So what's that comparison? Well, as a straight line, if you were going to the sun, you're talking 800 miles. You're talking walking across several states in the US. Okay? As I said, compared to Mars, if you were lucky and you got them on the same side of the sun pretty close to each other, you might have that. So you might, instead of walking, 2 miles down the block for your walk to the moon, right, by scale, and now you're talking about 400 miles. It's still a huge distance, okay? 2 miles you can do. 400 miles, not so much, right? So the idea that, that's the next logical stepping stone is a much bigger stepping stone than a lot of people are making it out to be, right? So scale is an important thing.